A pair of robot arms picks up a piece of fabric and hangs it flat. Another pair sorts objects into bins. Another folds a cardboard box shut. Every one of these runs is being steered, tested, or replayed through a pipeline built around human demonstrations, and every grasp, slip, and correction becomes data. This is ABC-130K, a new open-source dataset of robot manipulation episodes. It was released on June 17th by XDOF, a company that just came out of stealth with $70 million in reported funding. The dataset is free under Apache 2.0, and it is big. Over 130,000 episodes, about 200 bimanual tasks, and roughly 3,500 hours of recorded manipulation. To understand why someone would fund this at that scale, think about how large language models got good. They trained on the internet, billions of pages of text that humans had already written. Robots do not have that. The internet has almost no records of what it takes to grip a mug, how much force opens a lid, or what the robot's joints were doing when a towel fold failed halfway through. That kind of data, synchronized cameras, joint positions, gripper states, force readings, task labels, only exists if someone physically creates it. That is what teleoperation rigs are for. A human operator moves a pair of leader arms. A matching pair of follower arms mirrors the motion in real time. Cameras overhead and on each wrist record the scene. The control system logs joint angles, gripper positions, and timestamps. One completed task, folding a box, inserting a plug, sorting screws, becomes one recorded episode. Do that 100,000 times, and you have training data. The arms ABC-130K was collected on are called YAM arms, made by I2RT. They are designed to be cheap enough to run many stations at once. XDOF's pitch is that you can scale this into an operation, human operators generating episodes across task categories like pick and place, folding, insertion, tool use, assembly, sorting, and longer sequences like packing boxes or tying knots. The dataset feeds behavior cloning models. The ABC project trained two of them, ABC-DIT, a diffusion transformer, and ABC-VLA, a vision language action model. More data and more compute improved both. But training is only half the problem. You also need to know whether the robot still works when it leaves the dataset. ABC includes a standardized evaluation protocol with fixed rubrics and physical rollouts on real hardware, because offline loss numbers and simulation scores cannot prove a robot will reliably fold a shirt in a real room. XDOF also points to a simulation pipeline with about 400 hours of simulated teleoperation data, so researchers can iterate before spending real robot time. The useful claim is not that simulation replaces the lab. It is that simulation can help choose what to try next, while real-world evaluation remains the expensive ground truth. Here is the honest picture. XDOF has about 60 employees and reportedly around 20 customers, including unnamed frontier AI labs. They are selling the full operational loop: data collection, data cleaning, annotation, tooling, and evaluation infrastructure. The open dataset is their proof that the loop can run at scale. The trade-off is straightforward. Robot foundation models are getting closer to useful physical work. But the path there runs through data factories, rooms full of rigs, shifts of human operators, and teams cleaning labels and diagnosing failures. Scaling robot intelligence right now looks less like one clean software breakthrough and more like building an industrial operation. Whether that operation can move fast enough and get cheap enough is the open question.